In this part, we want to work on important ideas of combinatorics, and in total, we will work on more than 140 ideas, and I believe more than 45 homeworks. So after this part, we'll work on some important ideas of algebra, number theory, geometry, combinatorics. If you want to work on all important ideas of combinatorics, algebra, number theory, geometry that are useful for AMC, AME use somehow, feel free to send message to my WhatsApp number in the description. Okay, let's start. Okay. AMC 12B Fall 2021, problem 23. The idea here we want to use is useful in also AMC 10 and also AME. Okay. So try this problem first on your own. Okay, next idea is idea 134. The idea is what we can call it double counting or changing viewing angle. The professional name is double counting. Means what? Here, instead of considering from subsets, we consider from pairs. For example, look, if we consider 1, 2, 3, for example, 9, 11, then we have 1, 2, and 2, 3. So we want to calculate how many subsets contain 1, 2. So they have 5 elements, and it will be what? It will be 28, choose 3, because we should select 5 from 30 elements. 2 of them are 1 and 2, so 3 from the others. And for 2, 3, again, 28, choose 3. So for example, we calculate this subset twice, because it contains 1, 2, and 2, 3. Last one is 29, 30. Again, number of subsets that contain 29, 30 is 28, choose 3. So the answer is 29 times 28, choose 3, over all cases, which is 30, choose 5. Okay? And it will be what? 30, choose 5. Okay, let's simplify. 29 times 28, 27, 26, over 3 factorial, all over 30, 29, 28, 27, 26, over 5 factorial. If we divide, it will be 4 times 5, and 29, 28, 27, 26 will be cancelled with this. So it will be 4 times 5 over 30. So 5, 6, and it will be what? If you divide by 2, it will be 2 over 3. So the answer will be which choice? It will be choice A. Okay, if you want to learn ideas like these, as I said before, feel free to send a message to my WhatsApp number. Okay, let me tell you some problems related to double counting. Homework 36. An Amy problem related to double counting. It is for 21, 22, something like this. It is Sn sigma of An intersect Bn, something, or union, such that number of elements in A and B are subsets of 1 to n, and number of elements in A equals number of elements in B. Some problems, the problem was something like this. Okay, if you want to know exact problem, send message to my WhatsApp number. Next one is A and B are subsets of 1 to n. So for homework 31, try to solve how many A and B are there. Such that part A intersect B is null set. Part B, A union B is, for example, this set is X, and part C, for example, number of elements in A union B is 2. Part D, A subset of B. Part E, try to find sigma A union B. Absolute value means number of elements, norm of that. Part F, sigma A intersect B is what? Number of elements. Homework 38. For example, suppose A1 to AK. We have that subset is 1 to n. It is X. How many A1 to AK are there? Such that part A, A1 union A2 to AK is null set. There's not part B, A1 union, A1 intersect to AK. A1 intersect to AK equals null set. Number of elements here, for example, is 3. B, A1 union A2 to AK equals X. And part D, A1 is in subset of A2. Each problem, for example, is a problem of some Olympiad exam. This one, E is sigma A1 union A2 for all cases, number of elements. Sum of them is what? And F equals sigma A1 intersect A2 to AK. Okay? So solve these problems. If you want to solve more problems, as I said, send message to my WhatsApp number. Next problem Is this one AMC Fall 10, 8, 12, 8, 2021? Try this problem first on your own. Okay, for this problem, I've told you 134 idea, 135 in especially combinatorics problem. The most useful idea is considering small examples. So let's start with 1 and 1. F1 of 1 is what? Is twice the number of positive integer divisors. So 1 has one positive integer divisor, twice that will be 2. F2 of 1, we want to reach F50 of 1. By this definition, it will be F1 of F1 of 1. F1 of 1 is what? Is 2, so it will be F1 of 2. F1 of 2 has two divisors, two positive divisors, twice that will be 4. Okay, so 1 by taking F1 goes to 2, 2 goes to 4, 4 has 3 divisors, 2 times 3, 6. 6 has 4 divisors, goes to 8, 8 has 1, 2, 4, 8, 4 divisor, it goes to 8. Okay, so if you take, if you consider F50 of 1, you take 50 times F1, so it will be 8. So 1 is not good. Now 2 is not good similarly because F50 of 2 is 8. 3. 3 is similar to 2, it goes to 4. So we can say if P is prime, then it goes to 4. It's not good. So the next number we should check is what? 4. 5 prime, 6 here, 7 prime, 8 here, 9. 9 is similar to 4, is P squared. Okay, goes to 6. So P squared when P is prime again is bad. Next number we should check is 10. 10 is PQ. 10 has how many divisors? 1, 2, 5, 10, 4. We can use the formula is f2 to the 1 times 5 to the 1. 1 plus 1 times 1 plus 1. 2 times 2, 4. So 10 goes to 4. It has 4 divisors, sorry. Twice that. It's 8. Okay, so 10 goes to 8. Let's check it again. 10 has 4 divisors. 1, 2, 5, 10, or the formula if you use. So 4 times 2, 8. 10 is bad. PQ, if P and Q are prime, they go to 8. Okay, like this you can check up to 50. Try the rest on your own. Okay, let's consider other elements. We've considered 1, 2, 3, 4, p. And last one, 10. 11 is prime. 12 is p squared q. So 12 goes to what? Because 12 is 2 squared times 3. It is 3 times 2, 6. It goes to itself. Okay, so this one is good because it says F50 of n equals 12. So 12 is the first number that is good. 13, we don't need to check prime. 14, PQ. 15, PQ. 16 is P to the 4, 2 to the 4. So it has 5 positive divisors. 2 times 5, 10. So 16 goes to 10. So P to the 4 is bad. 17 prime, we don't need to check. 18 is good because it is P squared Q. We know P squared Q are good because it looks like 12. 19 prime, we don't need to check. 12 again is good because it's P squared times 5. 2 squared times 5. 21 PQ, not good. 22 is PQ, not good. 23 prime number, not good. 24. 24 is 2 cubed times 3. It's 4 times 2, 8. 8 times 2, 16. So it goes to 24, 16, not good. 25 p squared, not good. 26 pq, not good. 27 p cubed, like 8, not good. 28, good, because it's p squared q, 2 squared times 7. Okay, so try the rest on your own. Okay, so we've checked 28, 29 is prime, 30 is PQR. So 30 is 2 to the 1 times 3 to the 1 times 5 to the 1. 2 times 2 times 2, 8 times 2, 16. So 30 is not good, 31 not good, 32 is 2 to the 5. It goes to 12, 6 positive divisors, 12, so 32 is good. P to the 5 is good, but the only one is 2, because 3 to the 5 is greater than 50. 33 is PQ, 34 PQ, 35 PQ, 36 P squared, Q squared. Let's check. 36 is 2 squared, 3 squared. 3 times 3, 9. 9 times 2, 18. And 18 we know is good, so 36 will be also good. 37 prime, 38 PQ, 2 times 19. 39 PQ, 3 times 13. 40 is 2 cubed times 5. It is like 2 cubed times 3, which is 3 times 8, 24. 24 was not good, so this number also not good. 41 prime, 42 is PQR, like 30, not good. Okay, 43, not good. Prime, 44 P squared Q, 2 squared times 11. So 44 is good. 45 is 9 times 5, P squared Q. It's good. 46 PQ, not good. 47 prime number, not good. 48. 48 is 2 to the 4 times 3. Right? 5 times 2, 10. 10 times 2, 20. So 48 is good. 49 is P squared, not good. 50 P squared Q is good. So how many good numbers? 1. Let me calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, okay, so the answer will be 10, choice D. Okay, this problem from AMC 12B Fall 2021, and the idea we want to use is also useful in AMC 10 and also other exams. Try this problem first on your own. For this problem, let me tell the idea 135. Idea 136. Use recursive sequence to solve the problem. Okay. Try the rest on your own by using this hint. Suppose, for example, first we are in this point. After 5 moves, for example, when we go here, we cannot go here because the distance will be greater than 1. So, for example, we can go here or here or here. So, here we define this part A. And for example, here we want to find A5 after 5 moves. How many moves are there AN? When we start from A after N moves. And Bn is when we start from B and after N moves. In all steps, never will have be more than 1 unit away from A. Okay? So we define it as Bn. Start from B, An start from A. But both of them have this condition away from the starting position. In both of them, starting position, we consider A. Okay, in Bn also. So, for example, from Bn you can go here, here. It will be okay because the distance from A will be less than or equal 1. Now, for An we have 6 moves. 1, 2, 3, 4, 5, 6. 6, and each of them will be Bn minus 1. For Bn, if we go here or here, it will be 2Bn minus 1. If we go here, it will be An minus 1. Okay, now we try to find An in terms of itself. So here we can say Bn minus 1 is An over 6. So if we use this here, it will be An plus 1 over 6. Here it will be 2 times An over 6 plus An minus 1. If we multiply both sides by 6, An plus 1 equals 2An plus 6An minus 1. Okay, now A1 is what? A1 is after 1 movement, 6. A2 is what? 6 movements, and each of them has 3 options. 6 times 3, 18. Okay, and let's see the choices. It says what's the probability? Okay, so all cases will be what? 6 to the 5, because we have 5 movements, each of them has 6 cases. A1, A2. So A3 will be what? 2 times An, 2 times 18, plus 6 times An minus 1, plus 36, which is 72. A4 is what? 2 times this 144, plus 6 times this 108, which will be what? 8 plus 4, 12. We have 1, 5, 2, 5, 2. And A5 last one is what? 2 times this. So let's calculate A5. We want our answer is A5 over 6 to the 5. It will be 2 times previous one, 252 plus 6 times 72 over 6 to the 5. Okay. Now we divide both numerator and denominator first by 6. Will be 6 to the 4 here, 6. We divide 2, we divide this by 3, 8, 12, 4. Okay. Now again we divide both sides by 6, it will be 6 cubed. If we divide by 6, it will be 124, 4. And this one, if you divide by 6, it will be 1, 12, 2. So 12 plus 14, 26 over 6 cubed. Okay. Okay, so if you divide more, it will be 13 over 216 over 2, 108. So the answer will be which choice? Choice A. Okay, so look here, recursive sequence I-136. This part when we need extra recursive sequence for solving the problem. If you want to learn this, you can send message my WhatsApp number 137. And okay, how to simplify with I-138 idea with substitution here. Okay, you replace B in terms of A. This way is the best way. And okay, as homework, let me see how many homeworks do we have. Homework 38. Homework 39. We have a recursive sequence problem 0, 1 string in AMC. AMC both 10 and 12. Recursive sequence. Another problem related to recursive sequence, one IMO problem related to weights. It was for IMO 2013 or 2011. I should check. Homework 41 was Amy problem related to paths. We had a frog. I should find the problem was exactly what. And you can solve these problems with recursive sequence. And idea 138, idea 139. We have three ideas. Okay, idea 139, we have three ideas in paths. Numbering, permutation, and levels. In AMC also we have a similar problem, many problems. But you can use this also in AME. Idea 140, if you want to know exactly those three ideas are what, you can send message to my WhatsApp number. Idea 140 related to my caseworks, so much important. Homework 43, we have a problem in promise, ANGN related to casework. Homework 44, we have SUMAC problem, Stanford Summer Camp, 2022, 2022, if you want problem 8, Q8, and also Q7. Homework 45, Q7. 2022, Q7, question number 7. For casework, homework 46, one problem from AMC 1012, A 2022. It was J a string we had, and we could solve it with casework. I released the solution of that homework 47. A problem from AMC 12B 2022. We had some cells, black and white, filled or empty, and we had some actions. That one again can be solved with casework problems. Okay. And let me tell you another idea, idea 141 related to casework. In caseworks, the most limited one, you should focus on that. It's useful. Also, we have four ideas for game strategies that 90% of those problems can be solved with one of these four ideas in homework 48. We have a problem in AMC 1012. It is something like this. We have some figure like this, and you should find, for example, a strategy for one of the players. Win strategy. That, for example, always he will win. Homework 49, also USAMO 2023, USAMO or USAJMO, I think it was 2023 or USAMO. I don't remember exactly it was what. We had a game problem, and you should use one of these four game strategies problem. For example, one of them invariant, one of them symmetry going to the end of the game, n and f of n. If you want to learn them, as I said before, feel free to send message my WhatsApp number in the description. So we worked on 141 ideas and 49 homeworks. Okay. And as I said before, if you want to learn all important and background ideas that are useful in AMC, AME, USAMO, USAJMO, or other math exams, or want to solve more problems, want to get good at them, want to improve your problem solving, you can send message to my WhatsApp number.